Hello Paul and the most excellent community of developers. This is Xavier for the follow-up of Raspberry lesson 4 proposed by Paul McWhorter here. So this is the lesson I refer to, understanding and using GPIO pins. So let's go for it. Here, when we have a look at this lesson, we'll see that for here uses 330 ohm resistor for protecting the LED. The LED has a maximum current, of course, that we have to adapt with a resistor. And my problem is that when I have a look at this my kit here, we see that we only have 220 ohm resistors. This is not the exact value expected. It's because I bought the kit 1 year ago and there's been an update in between, I guess, or maybe a shortage of 220 ohm resistors. I don't know. Nevertheless, I want to be sure that it will not burn my Raspberry Pi if I use it. So what I did here is to check what can be done and what can be checked. And the first thing is to know what it's all about. I mean here, what are we working with? What are the constraints on the components? Here we see that we have a red LED. This is coming from the documentation in my kit, so maybe probably you have other values if you bought another kit, but in my case, red LED has a voltage ranging from 1.9 to 2.2, has a maximum current of 20 milliamperes and a recommended current 10. Okay, I will note it down here. Where did it go? Yes, here. So LED is 1.9, 2.2 volt on 20 milliampere max with a ROCO of 10 milliamperes. Okay, and what do we know? What do we know? We know Ohm's law. Pay attention. It's equal to resistance by intensity, by the currents. Yeah. More specifically, if we have a circuit with a resistor here and a LED going to the ground, yes, it's like emitting diode here, a little LED, and a resistor here, okay, with a plus here, okay. So if we want to fix up the things here, we will say that V in, which is here, plus V in is input voltage Okay, I LED is LED LED, what is called forward. It's a very good lesson about LEDs with Paul McWhorter to let you check this. LED forward current, of course. Forward. Yes. Okay, you see what I mean here. And a VLED is what is called LED voltage drop. Okay, and there's a formula binding all this, which says that RS is equals to V in minus V LED over what? Over I LED, which makes sense, of course. So we know the resistor, we know the voltages, and what we want to check is that the current is not too high, of course, because current too high would burn the circuits. So we can just reverse this and say that I is V in minus V LED over R, okay, which is 5 minus V LED, let's take about 2, okay, on what? On resistance, which was 220 ohm, volt, which is 3 volt over 220 ohm, which is about 3 about 15 milliamperes. It will be a little bit less because it's 220. If it was 200, it would be exactly 15. Okay, if you want to be sure, we can take our logarithmic table. No, joking, kidding. Yes, here 3 over 220 amperes, which gives 13.6 milliamperes. Okay, so this is approximate value, and exact value is 13.6. okay, let's say 14 milliamperes. Okay, because we are doers, we are not lawyers. Sorry for lawyers. Yes, about 14 milliamperes here. Okay, let's check this. Okay, what will we see here? Yes, multimeter. Okay, oh, it's moving. It's live. Try to make things right here. Okay, Well. Those are the lines. Yes. And as you can see, I plugged my resistor, my LED, and one more cable, just to be able to put my ampermeter between the two. My ampermeter is tuned on a 50 milliampere range, okay, which means that if I go full scale, it will be 50, and we only have ranges marked with 25, 10 and 5. Okay, we'll do it. It's not digital, it's an analog multimeter. So what happens if I yes, okay, no, hey, that's it. Oh, it works. No smoke, yes, yet. What do we see here? Okay, we see that on the range of 25 we have a value of what is it, 7, okay, 5, 6, 7, 7.5 maybe, on the range of 5, so it's a bit difficult to see. Okay, so this is 5, and this is 10. Okay, okay, which is 7 here. You can read 7. Sorry, I had to change my glasses to look at the range here. So each tick here has a value of 2, and yes, that's it. 5, 6, 7. Yes, it would be 7.5 with a half tick here. So it means 7 on a 25 range. 7 by 2 is 14, which is consistent with what we had here, 14. Okay, here. Yes, that's it. So it's consistent. We have what we expected. So most important is that 14 is of course above here recommended current, here. Recommended current was 10, but it's below the maximum 20. So it is a little bit bright, but it's okay. What would happen if I take 3 volts? Okay, if I take 3 volt output from the raspberry here, minus 2 volt, is 1, 2. Okay, 1 and 2 here would be about 4.5 milliampere. Okay, so what would happen? I will change here my pin to go to the 3 volt, which is here, I guess. Yes, 3 volt. Okay, it must be a little bit less. Yes, and we have about what is it? 2.6, yes. Okay, so this is about half. Yeah. Okay, 4.5 milliampere. Maybe I can change the range here. Yes. Okay, I put on a 5 milli. Oh, because it's 3.3 maybe. Okay, anyway, you see it's less, of course. 5.96. Okay. Okay, let's go back to 5. And that's it. Oh, pop, pop, pop. Yes, no, this is not good for the needle. Sorry, I'm just distracted. Okay, we go back on 5 volts here. That's it. Okay, so now we are sure it won't be a problem if we use this resistor. What else? Yeah, now let's go to the project itself. Okay, so yes, here enough with calculations. Whoa. This is long. Blinker. It was a blinking diode. Okay, so let's go here. This is my terminal. Messages. Okay, again. Yes, and now so I just import GPIO. Number, but I think that even you can translate it. Okay, let's go international. Okay, delay here. Oh, what is it? This one? No, this is the one I wanted to show you. Okay. So this is for cleaning up because I had some problems. Sometimes was forgetting to clean up, and things were still hooked to the Raspberry. So I just do a cleanup here in case. But if there is nothing to clean up, the system complains that error, there's nothing to clean up. So I do it in a try except here. Okay, if there's nothing to clean up, we just pass, so we just do nothing here. We need to make a pass because Python is based on indentation, so if it doesn't have one thing indented here, we'll complain too. Okay, we just here ask how many flashes we want, and we want a number. Always remember that everything coming from outside is string. Okay, system is based on strings, so we want integers inside. So we make a conversion, please convert. We convert our string into integer here, and we define here delay duration, so that our LED will flash in a way. We use set mode here with a board, and we will use the 11th pin here. Okay, set up in a output mode out here, and we will loop number of time requested here in line 10. Okay, the output here uses a Boolean, which can be which should be for fundamentalist true or false, but usually a true value can be understood as a one value. A one value, integer 1, will be interpreted as a true value, and a zero value, integer 0, will be interpreted as a Boolean false, which is interesting because we have here an operator which is modulo. Okay, modulo gives you the rest of integer division. Yes, so 2 modulo 3, or 3 modulo 2 will give you 1, 2 modulo 2 will give you 0, because there's no rest. 20 modulo 7, 20 modulo 7 will give you what? Will give you 6, because 2 times 7 is 14, 6 left. 21 modulo 7 will give you 0. Okay, so it's useful because you can easily make an alternate 0, 1, 0, 1, 0, 1, because any integer will always be modulo 2, 0 or 1, and just what we want here, because we want light or no light. Okay, so after each change we just ask here for waiting a certain amount of time, which is defined in line 13 here, and after that we just clean up, and that's it. I just have to change here my board to take this into account. Yes, and I will plug this here on the 11th pin. Okay, sorry, I have to get up one again. Where is the 11th pin? Maybe this one. 70. Okay, I hope it's this one. And no. How many flash do we want? I will just adjust the size here. We want 5 flashes. Oh, would you like this? Oh, there's a problem between Windows and things here. I will just start it again. Sorry. Boot. after a certain time there's a program for communicating between Windows and the Raspberry. So I have to start it all again. Please don't do that to me. Okay. Yes. What was it here? Yes, it's same here. Okay. Then we launch it. Okay. Oh, session restored. What do you want? Okay. Now 5. Yes. Understood me. 5. Oh, he's tired, I think. What's wrong with it? Okay, maybe we have to drop all the terminals and we just launch it again. Okay. Let's start with a once again. Okay. What's wrong with it? If it's not even able to do this, we'll have troubles. Okay, Jupiter. Okay, it's loading many things, discovering and this and that. We don't need this. Okay. Let's run it. Yes, as I told you earlier, I would like 5 flashes. Okay. We have a liftoff. Yes. And who can light a LED can light a fire. And fire is civilization. Okay, thank you for your patience. Thank you for watching. I hope to see you soon on the next Paul's premiere. maybe Tuesday, I think. Okay, have a nice Sunday, everybody. Bye. No. Bye. Yes. Can we just stop this, please?